In last video, when I tried to do the cross product between two vectors expressed in 3D orthogonal frame, I made a mistake. So in this video, I will show you clearly how to do it. In order to compute, this angular velocity vector cross product with linear velocity vector correctly, we have to cover the basics of cross product. So when you have two vectors, vector A cross product vector B, right? If we define the theta as the angle between them, the cross product actually is equals to the magnitude of vector A multiplied by the vector magnitude of vector B multiplied by the sine theta between them. And cross product itself also has a direction defined based on something called right hand rule. In this case, we do cross product between vector A and B. So right hand rule is going from curve from A towards B, and then your sum will point to the direction of the result. So essentially it's pointing into the page. So in terms of magnitude, it is this one, and the direction is defined by right hand rule. If we utilize that, then looking at the unity vector IB cross product with itself, what is it? And just as a review, this is unity vector of the body frame, where you have GB and KB. It's essentially x-axis, y-axis, and z-axis. This is called a frame defined based on orthogonal frame because they are all perpendicular to each other, and it's an orthogonal frame defined by right hand rule, where again your thumb point to the z-axis and your middle finger point to the y-axis. In this case, there is also an alternative thing like a left-hand defined frame, but we based on our convention on the right-hand defined frame. So this is obviously 0. Why is that? Because the angle between these two vectors are essentially 0 degree, and sine 0 gives you 0. What about the IB hat cross product with JB hat? That actually gave you, in terms of magnitude, is 1 times 1 times sine 90 degree, which is the sine 90 degree is also 1, so it's just essentially 1. But remember, this has a direction as well, and then apply right hand rule cross product from IB towards JB. It gives you the KB, right? So essentially, IB hat cross product with JB hat equals to KB hat. That's our second conclusion. What about the IB hat cross product with the z-axis unity vector KB hat? It is equals to 1 times the again apply right hand rule, curve from IB hat towards KB hat. It gives you negative JB hat. So with this, we know we can actually compute this mathematically already. So let's compute that. Essentially, the PIB hat plus Q GB hat plus R KB hat cross product with the UIB hat plus v GB height plus w KB height, and we just expand these two 0, right? So plus those two you know, essentially magnitude is PV, and apply this conclusion, it is like the KB height. And then we know this one cross product with W KB height, that's your PW and negative GB height, right? And we also need to expand the second term. You know, GB height cross product with IB height, you can prove to yourself is negative KB height. Actually, let's prove from JB height curve towards you know, from JB height curve towards the IB height, it gives you the negative KB, right? So here we have QU negative KB height, and here is 0. That is you know, QW, and GB height cross product with KB height, that gives you actually X, so IB height. That's the direction. Similarly, we expand the last term. That is KB RU, KB cross product with IB gives you GB, right? So that is JB height, and then KB and KB itself 0. Did I miss something? I think I missed RU. I missed RV part, and RV is you know, KB cross product with JB. Right hand rule, negative IB height. In this case, let's lump term together. When we lump term together, it is equals to you know, QW minus RU, I mean RV, and IB height plus in this case the RU minus PW JB height, and then PV plus actually minus QU KB height. So this conclusion is a little bit different than is it? It is. So last time we got like if we say this is negative, this is, you know, negative, and then we have Q, this right part, QW minus RV, and then this portion is where I made a mistake. It is actually equals to, you know, RU minus PW, right? So I think when you try to apply the shortcut, you have to be careful, otherwise you will make the same mistake. When we cross product, we need to say this position is at 0, 0, you know, 0, let's say 0, 1, and 0, 2, This is like 1 0 1. Sorry, I made a mistake again. You have to note the position that you crossed out. This is 0 0. This is the 0 1, and this is like 0 2. So when you cross out this one, when you apply the shortcut, this is like QW minus RV, and then you have to multiply it with the, in this case, -1 to the power of 0. And then when you have this term, you have to apply like -1 to the power of that's 0 plus 1, that's 1, right here. That's where this -1, additional -1 comes from, that I missed last time. And when you cross the k part out, meaning you are computing the k direction, it's PV UQ, and then this is like -1 to the power of 0 plus 2, which is equals to 1. So this is where I missed that -1 last time in last video. Hopefully I explained what's the definition of the cross product, the direction definition defined based on right hand rule, as well as now it's clear to you that how to compute two vector cross product of two vector in the defined in 3D orthogonal frame, like the body frame, as well as why that shortcut works, and then the caveat you have to remember. It's very easy to forget the -1 to the power of the sum of the position index. Thank you.